Uh, Good morning. Today I am going to explain the meaning of definite integration. It seems that difference in limits only. When you consider an integrand of this form, fx dx without limit, this is called indefinite integration. Because it will give us value of the integrand which is again a function of x plus a constant. But if we integrate within limits, this kind of integrands which you already have seen if you are a science student, you have seen in physics and chemistry, and economic students you might have seen in your subject. In some chapters this concept is required, but I don't know what level actually required, because economics I have very poor knowledge, but in higher economics I have seen there is application of this concept also. When you are finding a to be fx dx, this a is known as lower limit. A is called lower limit, and b is called upper limit. What is its meaning? Why are you suddenly integrating between the limits? As the introduction of the topic, I'll tell you the aim is very clear. When we are going to write within limits, we are going to find the area bounded by a curve with x-axis when boundary is irregular. If the curve is there, you cannot use length into breadth formula here. So how to find the area bounded by the curve with x-axis? This is our objective to find gradually. But before that, we'll discover this thing a to b fx dx is nothing but the limit of a sum. Limit concept you already got. Summation of series also you have the idea. We'll see that a to b fx dx is nothing but the limit of a sum. So let us consider a function, definite integration and limit of sum. When we are going to consider, we take a function which is defined in the interval a to b. That function be y equal to fx. It is defined from the point A to the point B on the number line. Better you take this point as a comma 0 and this point as b comma 0. This interval is of length b minus a. Suppose you divide the interval into n equal subintervals, each of length h. N intervals are there. This is a, this is b, this point is p1, point is p2. Okay, it's like this. This point be pn minus 1 and this point be pn. Okay, these are the points. Coordinate of this point can be taken as, x value if we take, can be taken as a plus h. This one can be taken as a plus 2h. This way pn can be taken as a plus nh. Then b minus a, the whole length of interval going to be equal to nh. Okay, or you can take that number of subdivisions equal to b minus a by h. And it is quite obvious that when h is tending to 0, when h is tending to 0, this implies that n is tending to infinity. Or opposite thing, when n is tending to infinity, if you have expressed in this form, When n is tending to infinity, it will imply h is tending to 0. Now the function is y equal to fx. Functional value here will be f of a plus h. This will be f of a plus 2h. This will be f of a plus nh. And that nh is going to be b minus a. Now if you consider this sum s1 equal to the functional value at this point, at the point x equal to a, is going to be equal to fa. If you consider the sum h into fa, h into fa plus h, h into fa plus n minus 1 into h. Why you are considering this sum? There is an explanation that I'll explain in area under plane curves part, but right now we are going to interpret that a to b fx dx as limit of sum. I'll be telling you that part mainly. So using summation sign, this can be written as r equal to 0 to n minus 1 f of a plus rh. This is one sum. Or if you like to find this sum, you can do same thing, but starting with this, starting with f of a plus h. So this will be h f of a plus h, h f of a plus 2h, and the last one h f of, so this thing changing to h sigma r equal to 1 to n f of a plus rh. Okay. Now when h is very small, so small that h is tending to 0, in that case this limit and this limit will coincide, because number of subdivisions tending to infinity, there is basically no difference between these two sums and these two sums. So under the condition limit h tending to 0, h sigma r equal to 0 to n minus 1, this will be equal to h multiplied by sigma f of a plus rh. Okay, and this will be referred as a to b fx dx. Okay, so this definite integration a to b of fx dx, what you have learned just now, it is basically the value of this limit h tending to 0, h sigma r equal to 1 to n f of a plus rh, where nh is going to be equal to b minus a. Okay, this I have shown here that n equal to b minus a by h, or h equal to b minus a by n. Now let us see one application. Suppose they have asked you to find this limit 1 to 2 2x plus 1 dx by using definite integration as limit of sum. For this sum, what is a here? A is 1, b equal to 2, so nh equal to 1, and what is fx here? Fx is 2x plus 1, so f of 1 plus rh will be 2 into 1 plus rh plus 1, So this sum, by using the definition in the previous article, is going to be limit h tending to 0, h sigma r equal to 1 to n 2rh plus 3. And this one you can write, if you put r equal to 1, 2h plus 3, this part will be 4h plus 3, 6h plus 3, two nh plus 3. Okay. Now, if you take the terms containing h together, it will be 2h into 1 plus 2 plus 3 up to n plus 3 this way up to n terms. So this thing going to be h, this sum is n into n plus 1 by 2 plus 3n. Take h inside, plus 3nh, where nh is 2 minus 1, that is equal to 1. That I wrote earlier. So you substitute the value here. It will be 1 into 1 plus h. If you put 0, then this is going to be 3 into 1. Answer is equal to 4. Okay. Similarly, if we consider another one, like say we are taking 0 to 1 e to the power x dx. For this sum, what is a? A is 0, b is 1. So nh will be 1. So this limit is going to be h sigma r equal to 1 to n f of a plus rh. A is 0. And what is fx here? Fx is e to the power x. So f rh is e to the power rh h multiplied by, just you put the value here, this is going to be sigma r equal to 1 to n e to the power rh. This will be h tending to 0, e to the power h, e to the power 2h plus e to the power nh. H multiplied by e to the power h, you take common, e to the power h, this divided by, now if you simplify it, it's going to be e to the power h into h by e to the power h minus 1. All we can see that because nh is equal to b minus a, and this thing is a, this thing if you separate, it will be limit h tending to 0 e to the power h multiplied by limit h tending to 0 h by multiplied by h tending to 0. So this will be 1, this is 1. Answer is e minus 1. Okay. So you have seen that both the sum was given in this form, its value is e minus 1. But some of you will say that it is such a painful calculation. Do we have to find that a to b a fixed x this manner and then it can do? No, you will not. You are not definitely going to use this procedure again and again. But to start the chapter, why definite integration? You must remember this. So long you study calculus, this concept will help you. That it is nothing but the limit of a sum. What limit? The limit h tending r equal to 0 to n minus 1 f of a plus rh, or r equal to 1 to n f of a plus rh. Okay. So in these two sums, where one is algebraic one, that 2x plus 1, and the other one is e to the power x exponential 1, you have learned the method to find the value of this kind of integration by using the concept of definite integration and limit of sum. But definitely when you apply fundamental theorem of integral calculus, then you need not do all these things. But it depends on the question given in your paper, in board paper.